The second video for Chapter 1 is 1.2, and we're going to use segments and congruence. This section we're going to talk about segments and congruence. The first thing is a postulate or an axiom. And an axiom is something that, or geometry rule that is accepted without proof. One thing that is slightly different from the last video was the distance between 2 points. Instead of just representing the whole line or just a segment from A to B, we can say that the distance from A to B is a certain length. So the way that we write that is with AB with nothing above it. Or we can also say BA, so that's also the distance from B to A. For the word between, the only way that a point C can be between A and B is if they share the same line, so if they are collinear. And if point D is off of the line, then technically D is not between A and B. So this next postulate is a big one we're going to use throughout the whole entire school year, and that's the segment addition postulate. And as you can see by my picture, that B is between point A and C. And so the segment addition postulate, if you think of what the name represents, that we're going to be adding segments together. So segment AB and BC, if I add those two lengths together, then it should equal the segment from A to C. What I have down here below is to set us up for the note cards that we're going to continue on. So there's a few from the first video that we can fill out together in class, and on these, what you're going to do on a 4x6 note card is on the front, we're going to write the beginning statement, so what we start with, and then once we have that information, then on the back of our note card, we're going to write what we then know. So this is what your note card should look like. As you can see on the left-hand side, this is what the front of your note card would look like. So a picture of the representation, and then you would be given some information. So if B is between A and C, then on the back side, this is what we can write because of that, and the reason why is because of the segment addition postulate. We're also going to talk about implied statements. So our implied statement would be, if B is between A and C, that's the first part of our statement, then this symbol right here means that we're implying, or that implies that, so our reason then is, or that AB plus BC equals AC. So this means that this is the if part of our statement, this is the then part, so if we're given this first half, then we can write this as the next statement. And the reason is still because it is the segment addition postulate, so that's still the reason you want to keep in line with that on your note card. Now is the time for you to try 2 questions on your own using the strategies we just talked about. So knowing that the 2 pieces equal the whole, that you can set up an equation and solve for the missing piece. So in this first one is distance from B to C. The second one you need to find the distance from M to Q. So there's some of them you need to find more than one step before you answer that final question. So remember, push pause, and when you're ready to check your answer, you can push play again. All right, now that you're ready to check your answer, this is what your answer should look like. In this first one, we can set up that AB plus BC equals AC, and because of that, we know that AB is 26 and AC is 59, so we can set up our equation this way and then solve for the BC. So we end up getting 33, and that is the piece that is missing. Here's your answer for number 2. The first thing we need to do is set up and find out what NP is. So segment NP ends up being 13, so if we write that back into our problem, then we can answer the question for MQ. As you can see, we can set up all 3 segments individually. If we add all 3 of those up, it equals MQ, the longest, or the whole segment. So if we substitute those values back into it, so 10 plus 13 plus 15, then we get 38 for our distance from M to Q. This next one is about congruent segments. And segments that are congruent means that they have the same length, so the distance between the 2 points are equal. So there is a slight difference between equal and congruent. So equal means that the actual lengths are the same, so the measurements are the equal distances. If they are congruent, that just means that the 2 objects are the same size, so that one segment is the same size as another segment. To show that 2 segments are equal lengths, we can see that the numbers are actually equal to each other, so the distances are equal. So we can say that segment AB is equal, or the distance from A to B is equal to the distance from C to D. And as you can see, remember that the equal sign means that it's actually equal, and if there's nothing above those letters, that means it's the distance from A to B. So we use, this is the correct symbols to show that the 2 lengths are equal to each other. If we want to show the 2 segments are congruent to each other, this is what this would look like. As you can see from my picture that we have two segments drawn. I have no idea how long they are, and it doesn't matter because we don't care about the actual measurement. We just care that it's one object, so it's a segment and another segment. This line drawn through it shows that they are congruent to each other, and the notation then shows that segment AB, notice this segment above it, is congruent. That's what this symbol means, is congruent. So it's an equal sign with a little squiggle or tilde above it, and then is congruent to the segment CD. And remember, we have to have the line or the segment portion above CD to show that it's a segment, versus over here in green means that this is the distance from A to B and the distance from C to D, so there would be numbers in your problem, versus congruent, there would be no numbers necessarily drawn for the length of a segment. Down below, we're going to be filling out some note cards based on this idea, the differences between those. So one thing is we can interchange between equal and congruent as long as we state the reason why. So if we have two distances are equal to each other, and then we want to say that the two segments then are congruent, because that would make sense that if they're equal, they're also congruent, that we need to say it a certain way. Or if we start with the two segments are congruent to each other, and we want to say now that the two lengths are going to be equal, we also have to say that a certain way, and a way to explain why we can say that. And this is what the two note cards are going to look like. So again, we're going to have something on the front, something on the back, and then we have two separate ones you're going to be filling out on this one. So the first one is if we have that the two lengths are equal to each other, and you can draw the same picture up here, you can draw it on the front of your note card. So if we have two distances are equal to each other, then on the back side we know that segment AB is congruent to segment CD, and the reason because is the big reason, is because equal measures implies congruence. And there's a way that you can write that in an abbreviated way, and this is what that could look like. On your next note card, we're going to do basically the opposite. So we're going to start with, if we have the two segments are congruent, then on the back side we're going to say AB is then equal to CD, and then we're also going to flip this reason around. So because congruence then implies equal measures. And this is what it would look like. So this is the abbreviated version here in red, and the abbreviated reason up there in the green. So a faster way of writing that equal measures implies congruence, or that congruence implies equal measures. So make sure you write these down on two separate note cards. On this last question, I would like you to try it on your own. So remember that we need to take into account all the things you've been talking about and look at the key words in here. So it says S is between R and T on RT, so you need to make sure you draw your segment, and then you want to use that information to set this up. So make sure you label your picture is the biggest thing, and then a hint on this one, you're going to use the segment addition postulate to help you set up an equation using those variables and terms. All right, now that you've tried your question, this is what your picture should look like. Next, you would want to set up your equation, so it should be 2x plus 10 plus x minus 4 should equal 21. Once you solve your equation, this is what it should look like. And don't forget to reread the question of what they're asking you to find. You need to find RS and ST, not just the X, and that will happen quite often this school year. So you need to take your 5 and put it back into the RS equation and into the ST equation, and this is what you should get for your solutions. As you can see, RS comes out as 20 and ST is 1, and if you want to make sure you check for reasonableness, that if we add those two segments together, it does equal the total segment length of 21. So on the challenge question down here below, I want you to try this one as well, just like we did on the other ones, and I want you to try to bring your answers to class tomorrow and see if you can get it correct. See you tomorrow.